Good morning, guys. Today we're going to look at tangent and cotangent, their graphs, like we did sine and cosine the other day. So let's step back to the unit circle for a moment. And we get this collection of points. I've added a few more than what we used for sine and cosine the other day, and you'll see why here in a moment. But let's just start by taking these points and stretching them out across the x-axis so we get that same relationship of the unit circle back to some graph on the xy plane. Now, if I'm looking at tangent of 0 radians, tangent, if we will remember, is y over x. So if I look at each of my points, say I'm here at 0 radians, looking at each of my points, I'm here at 0 radians, x is 1, y is 0. So when I do y over x, 0 over 1, I get 0 for my height, or for my value, my y value. Now if we'll go on around to pi over 2 radians, I do y over x, 1 over 0. Well, 1 divided by 0 is undefined, so that tells me at pi over 2, I'm undefined. I have a vertical asymptote there, just like we did with our rational functions. We rotate on around, keep working to pi radians. 0 over negative 1 is 0 again for pi radians. Keep coming around to 3 pi over 2 radians. Negative 1 over 0 is undefined again at 3 pi over 2. And then we work our way all the way back to 2 pi. Puts us back here. 0 over 1 is 0. Now, as we can see, by these points, these same angles with sine and cosine, we were able to build a nice curve. Well, here I see x-intercepts and I see vertical asymptotes for tangent, but I don't really get a curve. I don't get an idea of what the shape of that is for all the points. So that's where we bring in these other angles at. Now, I just like to work with 45 degrees, and the reason is because it gives us a nice, neat value to work with, because we remember, since tangent is y over x, and for 45 degrees, or pi over 4 radians, we get square root of 2 over 2, or some positive or negative version of square root of 2 over 2 for both the sines and the cosines. So that helps us out because when I do y over x at pi over 4, square root of 2 over 2 divided by square root of 2 over 2, it doesn't matter what the number is. If it's a number divided by itself, it equals 1. Rotate around to 3 pi over 4, negative square root of 2 over 2, and square root of 2 over 2. So y over x is going to give me a negative 1. Okay. So we're at negative 1 for 3 pi over 2. 3 pi over 4. So I've got pi over 4 and 3 pi over 4. So we're just filling in all these other gaps on the graph. And then we keep coming on around to 5 pi over 4. Negative x and negative y gives me a positive 1 again. On around to 7 pi over 4. Negative y over positive x is going to give me a negative 1 again. So I can see 5 pi over 4 and 7 pi over 4. So we get a whole lot of points in here. But the idea is the curve that we should see start to form for the tangent function. Because we know that we run parallel or right up next to vertical asymptotes, but we don't ever cross it. So I can't curve this here like we're crossing it. It's got to run up to where it runs right along the side of it. So we get this shape for our tangent graph. Now that's very crowded. It's a whole lot of points, a whole lot of information. Well, what we want to do is we always talk about one cycle of a function. Remember with sine and cosine, for y equals sine of x, we only looked at this shape right here because once I got here, it started to repeat the shape. Or for cosine, we looked at this shape here because once I went past here, I started to repeat the shape. So we're going to look at one cycle. Well, one cycle, when do we start repeating the shapes? I've come from the origin up to the asymptote, then from the asymptote back to the origin. Well, back to the x-axis. Once I cross the x-axis, I get the same shape. So one cycle is really not one full rotation. We get one cycle just from half of a rotation. Pi units, an angle of pi is going to give us 1 full rotation. Where with sine and cosine, we had to go all the way to 2 pi to get 1 full cycle. Here we only have to go half a rotation, 180 degrees from one point to the next, from one angle to the next, to complete that 1 cycle. So we clean this up by actually centering it on the at the origin. If we center it at the origin, and we'll just break this thing apart, pi over 2 was our vertical asymptote. Pi over 4, we were at 1. At 0 radians, we were at 0. Now, if we're just following our pattern we've been working with, whether I'm doing it here, where I decrease from right to left, or I move it around the origin, it's repetitive, so I'm going to get the same shape. So at negative pi over 4, which negative pi over 4 will be the same thing as 7 pi over 4, it's still negative 1. So it's still negative 1 right there. And negative pi over 2 is still the same as 3 pi over 2, which was undefined, so undefined over here. And I'm going to get this graph right here. This is the way we graph 1 cycle of a tangent function. We move this thing and center it around the origin and look at the cycle as it happens to the right and left of the origin. We look at it as a quadrant 1 and quadrant 4 graph instead of all 4 quadrants like we did with sine and cosine. So this is our shape of a tangent function, 1 cycle of the tangent function. Now as you can see, we don't get a true amplitude with this, but what we get is we know what's happening at the midpoint, because pi over 4 is halfway between 0 and pi over 2. So we know what's going on at the midpoint. That's going to be equal to 1. So that's where our values that affect amplitude are going to occur. That's where we're going to stretch things out vertically. Now let's go and look at cotangent. Remember, by definition, cotangent is the reciprocal of tangent. So we just flip all of these values over and it should give us our cotangent graph. So let's look at that. Cotangent is 1 over tangent of x. Well, if I take at 0, we were at 0. Well, the reciprocal of 0 would be undefined. So that means cotangent is undefined at 0 radians. At pi over 4, we were at 1. Okay? Well, what's the reciprocal of 1? 1. So that doesn't change. At pi over 2, we were undefined. Well, the reciprocal of undefined is 0. So we're now at 0. 3 pi over 4, we were at negative 1. Reciprocal of negative 1 is still negative 1. At pi radians, we were at 0. Reciprocal of 0, because it's 0 over 1. So when I flip that, it becomes 1 over 0. So the reciprocal of 0 is undefined. So we should start to see our curve taking shape here. At 5 pi over 4, we were at 1. So reciprocal of 1 keeps us at 1. At 3 pi over 2, we were undefined. Reciprocal of undefined is 0 again. At 7 pi over 4, we were at negative 1. So the reciprocal of negative 1 is still negative 1. 3 pi over 2 is kind of in the way. And at 2 pi, we were at 0. Reciprocal of 0 gives us undefined. Now what we can see is we're going to get the same shape. It's just going in a different direction. Well, that goes back to the same thing we talked about with sine and cosine the other day. The definition, the relationship between sine and cosine is that they are cofunctions. One is a 90-degree shift and a horizontal reflection of the other. So that's all we've done here. We've taken this graph for tangent and we've shifted it 90 degrees and then we've flipped it over. So when I shift it 90 degrees, now instead of it being at the origin, it's at pi over 2. It's at pi over 2. Well, when we flip the whole graph, instead of them increasing from right to left, now, or from left to right, now they're going to decrease from left to right, which is the picture we get for tangent, for cotangent. So when we build one cycle of a cotangent function, we actually see that from 0 to pi. So it's the same distance, it's only half a rotation to get that cotangent picture, that one cycle of a cotangent picture, but we can actually put it in here from 0 to pi. We don't have to move back across the x-axis into negative angles like we did tangent. So we get it as vertical asymptotes at 0 and 2 pi. It crosses the x-axis or the sinusoidal axis, like we have a sine, that horizontal line that went through our equilibrium points. And we've got positive 1 at pi over 4, negative 1 at 3 pi over 4. So that is one cycle of the cotangent function. Let's go ahead and look at how the different pieces of the equations affect the transformations of these graphs. Okay, guys, let's now look at how the different portions of the equation actually affect the graph. Now, as I said before, since we're increasing and decreasing, we're always moving towards positive and negative infinity within our range, we don't get an actual amplitude. Amplitude kind of talks about the maximum displacement from the equilibrium like we had with our sine and cosine graphs. So when I talk about amplitude on tangent, cotangent, I'm really talking about what's going on at the midpoint between where we hit equilibrium, where we zero out, and where we're at our asymptotes. So what's going on at that midpoint? So that's what I'm calling my amplitude. And it's still going to be affected by A. That midpoint was always 1. So tangent of that mid value is going to give us 1. Well, whatever we multiply by that's going to give me the height at that point. So that's what absolute value of A does. Next thing we'll look at is, and you can see that's just true for both tangent and cotangent. Next thing we'll look at is vertical shift, just like we did before. Vertical shift is what we add onto the outside of our function. So that's what K is going to be. It's going to move that equilibrium from the x-axis up or down, however many units it specifies. Horizontal shift is still going to be H, because it's what we were subtracting from the x values. So for the horizontal shift for tangent is going to move where we cross the origin at. It's going to move that right or left. For cotangent, remember, it's going to move that first asymptote that we're working off of. So it's going to move that right or left. Period, we talked before, it's only half of what sine and cosine's period is. So period is going to be pi over b for both tangent and cotangent, because it only takes half of a rotation. That doesn't really impact the graph. It's just kind of a good check that we have to make sure we do have the correct width on our final product. The important thing is really the increments. The increments before, we always said that it was period over 4 was the same thing. Pi over b over 4 is pi over 4b. And it's how far is that one block. So it's really going to tell me how far to that midpoint where I can really look at what my amplitude or my height at the midpoint is. It's going to be the same for both tangent and cotangent, because remember, they're just the same graph flipped over and shifted left and right. So the way we work with them and build them, they're going to do the same things. The big difference is the direction in them. The direction, if we're looking at tangent, just like with sine, if A and B have the same sign, it's going to be an increasing graph. So it's going to increase from the origin. If A and B have different signs, one's flipping it vertically and the other one's leaving it alone, or the other one's staying same vertically and then flipping it horizontally, that's going to flip our graph over. So it's going to decrease coming out of the origin or out of that equilibrium line. Now with cotangent, remember cotangent was my tangent curve flipped over, so it was going in the other direction. It was that horizontal reflection. So here, if A and B have the same sign, it's going to be decreasing coming out of the asymptote. Remember, it starts out coming out of an asymptote instead of the origin. So it's going to decrease coming out of the asymptote. And if A and B are different signs, it's going to increase coming out of the asymptote. And you can always, if you've got your calculator in front of you, you can type y equals tangent just to give you a reminder of the direction tangent should start. And you can type y equals 1 over tangent to give you a reminder of the way cotangent should start. But we really just want to see how the signs A and B affect whether we're staying to the original picture or reflecting that. So that's the way each of the portions affect the, or within the function, affect the actual graph. Now let's go actually graph some tangent and cotangent functions. Okay guys, let's actually graph a few of these now. So we've got the function y equals -2 tangent of x minus pi over 4 plus 1. So we've got a lot of different transformations in here. So let's just go through our checklist. Starting with the amplitude, remember the height at those midpoints, that was absolute value of a. Well, a is -2, so absolute value of a, get a better marker here. If I've got absolute value of a is what I want, absolute value of -2 is 2. So we're going to be at a height of 2 values, or 2 units when we're at those midpoints. Vertical shift was k, so that's 1, so it's going to be up 1. Okay. Horizontal shift was h, which is pi over 4, so that means right pi over 4. Period was pi over b. Pi over b, which b is 1 in this case. So we got a period of just pi units. So our overall width should be pi when we finish. Increments, if you remember, was pi over 4b. So pi over 4 times 1 gives us just pi over 4. That's how wide each block is going to be. And then the direction to finish out. Remember, for direction, we looked at the signs on A and B, -2 and +1. Signs are opposite, so it's going to flip our graph over. So if the signs are opposite, we're going to be decreasing from the origin. So we're going to decrease. We're coming from the origin. Remember, specify from the origin or from the asymptote, because remember, tangent comes straight out of the asymptote at 0, and cotangent comes straight out of the, tangent comes out of the origin at, tangent comes out of the origin, and cotangent comes out of the actual asymptote. Now we've got all our information we need, and this is my beautiful handwriting. Let's put it all together. So let's just look at where we're going to start. Amplitude is 2, but our vertical shift is 1. So we're not working right here off of this axis anymore. Okay. We're actually going to have to move our axis up 1. So let's go through, and I'll put a dashed line up 1. Now, this is going to be my new equilibrium line, my new axis where everything centers off of. So we're going to go up 2 from there. So that would put us at 3, and down 2 would put us at -1. So that'll be my height at my midpoint. Horizontal shift, well, that's where we start our actual calculations. Typically we start at 0. Now remember, tangent starts at the origin and goes 2 to the right and 2 to the left. Remember, we get plus pi over 2 and minus pi over 2 because we're going quadrant 1 and quadrant 4. So we're going to start at the origin usually, but we have a horizontal shift, so I've got to add pi over 4 to that. So now we're starting at pi over 4. We're just going to go through and do the arithmetic on this. Start at pi over 4. Now I want to go right pi over 4 twice, and I'm going to go left pi over 4 twice. So this is going to be my center. I'm going to go right pi over 4. Pi over 4 plus pi over 4 is 2 pi's over 4, or pi over 2. Okay. Pi over 2 plus another pi over 4. So 2 pi over 4 plus 1 pi over 4 gives me 3 pi over 4. So there are my 2 values to the right of the center. Now we're going to go left. Pi over 4, my center, left pi over 4. So minus pi over 4 gives me 0. Pi over 4, 0 minus another pi over 4 gives me negative pi over 4. So I've got my 2 points on the left, my 2 points on the right, and my center. All right, let's get our decimals on those as we start putting them together. So we know negative pi over 4. Negative pi over 4 is about negative 0.8. You can just punch that in the calculator. So it should be about right here. So there's negative pi over 4. 0 is obviously going to be here at 0. Pi over 4 will be positive 0.8, so it'll be about right here at pi over 4. Oh, I went negative 1.8, didn't I? And you go negative 0.8. So x pi over 4, 0, negative pi over 4. Then we need to go to pi over 2. Pi over 2 is about 1.6. So pi over 2 would be right here. We need to go 3 pi over 4. 3 pi over 4 is about 2.4. So 2.4 is about right here. And we just build our graph. Remember, this is the full cycle. Okay, and it checks out with our period. Negative pi over 4 to 3 pi over 4, that's a full pi radians or pi units. So the width is correct. What do the ends of one cycle look like? Well, I'll go ahead and draw my end lines, my vertical asymptotes on the ends. Okay. The center is going to be where we're zeroed at, my equilibrium, my pi over 4. And then we just put our direction in. Direction, we decreased coming out of the origin, out of our equilibrium point. So I'm going to decrease. So that means at my next point, my pi over 2, I've got to be at the bottom of my amplitude. And going to the left, then, I've got to be at 0, which is my point to the left. I've got to be at the top of my amplitude. So that gives me my tangent graph. Very similar to how we put it together for the sine and cosine. It's just a different picture once we've got all of our points labeled on it. But we're still going to assemble that equation or that graph the same way. So remember with tangent, when I talk about starting at 0, it's not like sine and cosine where I start at 0 and I just add. 0 is actually that middle point. So I'm going to start at 0 and I'm going to go 2 to the right. So I'm going to add the increments twice and 2 to the left. I'm going to subtract the increments twice. And that's going to give me my full picture. Outside values are my asymptotes and the inside is going to give me my curve. Let's look at a cotangent graph. Okay, let's say we have this function, y equals pi over 5 cotangent of 3x. So we go through the same process. Identify the amplitude. Amplitude is absolute value of a, so absolute value of pi over 5 is going to give us pi over 5. Well, what's pi over 5 mean? We'll approximate it. Remember, the whole point of us using radians was to take this large scale of 0 to 360 and pull it down to 0 to 6.28, 0 to 2 pi. So it's just to give us a smaller, easier to work with scale. So when I see pi, don't think of it as pi, some vague number that doesn't mean anything. It's approximately 3. Okay, so 3 divided by 5 is approximately 0.6. So that means my heights are going to be up about 0.6. So we took them from 1 where they typically are, and we've shrunk it down to about 0.6. It's a vertical shrink right there. Now vertical shift is k. We're not adding anything on the end, so there is no vertical stretch. Or sorry, vertical shift. So we get to stay, actually if you want to draw it out, we get to stay right here on that x-axis. We didn't move our equilibrium line where everything zeroes out at. Horizontal shift is what we're subtracting. That's none on this one. Period. Pi over b. Well, b is 3 in this case, so the period is pi over 3. So we should have a full length when we finish of pi over 3 units. Increments are pi over 4b. So that's going to be pi over 4 times 3, which is pi over 12. So we're going to add pi over 12 every chunk. And then we look at the direction. So we look at a and b. Signs are the same, so it doesn't matter if it was this or this, they would both give me the exact same picture. So if the signs are the same, that allows me to know that cotangent is going to stay its normal direction, which is decreasing from the asymptote. So while tangent comes out of the origin, comes out of that equilibrium line at 0, cotangent comes out of the vertical asymptote at 0. So we're going to say decrease from the asymptote. That gives me an idea of how to piece together my picture. So let's go through and draw this and put all this information down. Let's get our start. Just like before with with tangent, I'm going to start at 0. But remember our cotangent graph, we didn't go 2 to the right, 2 to the left like with tangent. It had already been shifted 90 degrees. So we just went like sine and cosine. We went 0 and then we went 4 increments to the right. So that's my starting point. And then I'm going to plus pi over 12 because my increments are pi over 12. So my first mark is at pi over 12. Plus pi over 12 gives me 2 pi over 12, which is pi over 6. Plus another pi over 12. 3 pi's over 12, which is pi over 4. And then another pi over 12, which gives me 4 pi's over 12, which is pi over 3. So that's going to be each of my marks. So let's go through and label. Well, there's 0, easy to see. Pi over 12 is approximately 0.3, so it would be about right there. This one, see, I had to stretch it out because I've got a lot of very tiny numbers. Pi over 6 is going to be around, it's like 3 over 6. It's very close to a half. Pi over 6 is about a half. Pi over 4 is about 3/4, so it's going to be close to pi over 8, or sorry, 0.8. And then pi over 3 is almost 3 over 3. Pi is a little bit bigger, so we'll put it just past 1. It's about 1.05. But you can see my spacing is pretty consistent for all of them. So there's my graph. There's my x-axis values. Now let's just go through and build the graph. The outsides for tangent and cotangent are always your vertical asymptotes. The middle value is where we reach the equilibrium, where we zero out. And then we just use our direction to put together the rest of it. Now, direction was decreased from the asymptote. So that means from the asymptote, I've got to be going down. So I start high and work my way down. Well, how high? Well, the height would be my amplitude, my pi over 5, which is approximately 0.6. So there's pi over 5, negative pi over 5. So I'm up here at 0.6 roughly, and then I'm decreasing. So then at my other side of the equilibrium, I should be at negative 0.6. So there is my tangent graph, or cotangent graph. And you get a lot of information kind of crammed into these pictures. So be very careful about your scale. This one probably would have better if I stretched it out a little bit more to give myself a little bit clearer image, but you're able to do that better on your paper. So be very clear, especially on your homework, so that when you're going back and looking over and studying, that you're clear about which points go where and came from where, so that when we get it into a test scenario, when you actually need to do these for when it counts, you have a good understanding of where those points fit and where they came from. And now that's tangent and cotangent. That's really all there is to it. Same idea as sine and cosine. We just get a different curve once we build those points. All right, see you in class tomorrow, guys.